Hi, good day. I'm John Dale Gutierrez, and I'm here to present a paper review about deep learning and neural networks. To start, this is my presentation overview. So I will start with the author, objectives, methods of the research, findings, and the gaps of the studies. So let's start by knowing the author. So the author of this research study is Sarat Kumar Reveiw from the Open University, UK. So the next slide would be the objectives. The objective of this research is to have fundamental concept on deep learning and to discuss about its current and future application. To understand about deep neural network and what is supervised and unsupervised learning, how to train deep neural network, various algorithm use, application of deep neural network. So the methods of this research is more on gathering data from different sources. So the research paper relied to the collected information and facts from the author's references about the artificial neural network, theoretical and technological foundations of deep learning, literature review about deep learning, emerging technologies, innovations, and applications. So the topics that was used by the author, so this was the topic used by the author in order to dig down information and to understand more about the deep learning in neural network. So the next slide would be the findings. So based on the information and facts gathered by the author identified the following findings. So the application of deep learning in augmented reality and pedestrian collision. Uh, the deep learning also shows promising scope in the field of image, video, and speech recognition. Deep learning can also be applied in the field of robotics using object recognition, where a robot can detect and grasp an object in a room. So the last slide would be the gaps of the study. During the study, the author identified some questions about a specific topic in the research, which is the deep architecture that remains unanswered. So the author identified questions about the deep architecture which is remain unanswered. So the first one is there a depth that is mostly sufficient for the computations necessary to approach human-level performance of AI tasks? Number two, how efficient is the greedy layer-wise algorithm for training deep belief networks in terms of maximizing the training data likelihood? Is it too greedy? Then number three, are there other efficiently trainable deep architectures besides deep belief networks, stock autoencoders, and deep Boltzmann machines? And the last one would be, how can deep architectures be generalized to represent information that by its nature might seem not easily representable by vectors because of its variable size and structure? So common example would be the trees and graphs. So that would be all about my presentation. Hope you like the video. Thank you, and God bless us all.